Hi, welcome to the WTAMU Virtual Math Lab. This video will step you through College Algebra Tutorial 20, Example 3. In this example, we want to solve the equation x squared plus 3x quantity squared minus 8 times the quantity x squared plus 3x plus 16 equals 0, which is quadratic in form. In step 1, we want to write the equation in standard form. An equation is quadratic in form if it can be written as a times some base being squared plus b times that same base plus c equals 0. This equation is already in standard form. The base that we are working with here is x squared plus 3x. In step 2, we want to substitute a variable in for the expression that follows b in the second term. Let's go ahead and use the variable t for this. Since we have it written in standard form, t will equal that base of x squared plus 3x. Next, we need to substitute t in for x squared plus 3x in the original equation. We have a base of x squared plus 3x being squared, so when we substitute t in for x squared plus 3x, we start with t squared minus 8 times, and we have another x squared plus 3x, so we'll replace that with t plus 16 equals 0. Because we started out with an equation that was quadratic in form, we now have a quadratic equation to solve. In step 3, we need to solve the quadratic equation created in step 2. If you need a review on solving quadratic equations, feel free to go to College Algebra Tutorial 17. Since this quadratic does factor, let's go ahead and solve by factoring. Factoring the trinomial on the left side, we will get t minus 4 times t minus 4 equals 0. Since we have a product of factors set equal to 0, we can use the zero product principle and set each of these factors equal to 0. Since both factors are the same, we only need to do this one time. So we will get t minus 4 equals 0. Doing the inverse operation and adding 4 to both sides, we get t minus 4 plus 4 equals 0 plus 4, which will simplify to be t equals 4. Even though we have found a value, we are not done yet. Keep in mind that we are finding a solution to the original equation and that the variable we substituted in for in step 2 is not your original variable. We still need to find out what x is equal to. We need to do step 4, which is to find the value of the variable from the original equation. We can use the substitution that was used to set up in step 2 and then solve for the original variable. In this problem, t equals x squared plus 3x. Let's see what x is when t equals 4. Substituting in a 4 for t, we get 4 equals x squared plus 3x. It looks like we have another quadratic equation, so we will need to solve this in the same manner as we did the other. We need to subtract 4 from both sides to get this in standard form, so we have 4 minus 4 equals x squared plus 3x minus 4, which will simplify to be 0 equals x squared plus 3x minus 4. Factoring that trinomial on the right side, we get 0 equals x plus 4 times x minus 1. Using the zero product principle, we can set this up in two equations of x plus 4 equals 0 or x minus 1 equals 0. Solving the first equation, we can do the inverse operation and subtract 4 from both sides and get x plus 4 minus 4 equals 0 minus 4, which simplifies to be x equals a negative 4. Solving that second equation, we need to add 1 to both sides and get x minus 1 plus 1 equals 0 plus 1, which gives us x equals 1. Even though we have found two solutions, we still want to do step 5, which is to check the solutions. In some cases, we will be working with rational exponents and square roots in your problems. Those types of equations can cause extraneous solutions. Recall that an extraneous solution is one that is a solution to an equation after doing something like raising both sides of an equation by an even power, but it is not a solution to the original problem. Even though not all the quadratic form equations can cause extraneous solutions, it is better to be safe than sorry and just check them all. Plugging -4 in for x into the original equation, we will get -4 squared plus 3 times -4, and that whole quantity squared, minus 8 times the quantity -4 squared, plus 3 times -4 plus 16 equals 0. This will simplify to be 16 minus 12 in that first parenthesis squared, minus 8 times 16 minus 12 in that second parenthesis, plus 16 equals 0. This will simplify to be 16 minus 128 plus 96 plus 16 equals 0, which gives us 0 equals 0. Since this is a true statement, that means x equals a -4 is a solution to this equation. Next, we want to plug in 1 for x into the original equation, and when we do this, we will get 1 squared plus 3 times 1, that quantity squared, minus 8 times the quantity 1 squared, plus 3 times 1, plus 16 equals 0. This will give us, in the first parentheses, 1 plus 3, and that's squared, minus 8 times the second parentheses of 1, plus 3, plus 16 equals 0. This will simplify to be 16 minus 8 minus 24 plus 16 equals 0, which gives us 0 equals 0. Since this is a true statement, that means x equals 1 is a solution to this equation. So our final answer is x equals -4 or x equals 1.